Hi guys. So, I'm not going to talk to you like face to face like this on the recordings much. I just wanted to say hey, and I'm really sorry that we're having to do it this way. Definitely not how I felt like the rest of the semester was going to go, but we will battle through it together. And mostly what I'm going to do is put the PowerPoint up and I'm going to talk and just do it like we would in class as if I was doing it on the Elmo. So if you have any questions during anything, just don't hesitate to message me through Remind or send me an email. If you have a specific question on on a problem or something, try to send a picture so that I can reference it because sometimes the numbers are different and things. All right, so I have set up a Zoom meeting for tomorrow, and I'll remind you of that, guys, before it happens. But I would like everybody to try to do the Zoom meeting. I will do attendance, and I will kind of show you how to kind of navigate through D2L and go through these lectures and kind of what's to be expected. All right, so I'm going to switch over to the PowerPoint now. All right, so because I know that we got through maybe half of the PowerPoint, but it's just been a long time, so I'm going to go through the whole thing again on chapter 6. If you are comfortable with, the beginning part of chapter 6, then you can just skip forward to where we left off. If you need a little bit of a recap, maybe this will help. But that's kind of the good thing, I guess, about this is that you can kind of rewind and fast forward, I guess, if you want to. All right, so I'm going to go ahead and play it. Yeah, there we go. And basically, we just talked about at the beginning of chapter 6, hey, remember that we're thinking of forces that are like in equilibrium. So just like this bridge that it's showing here, all of these forces are they're not moving. So they're at rest or something is in constant velocity, then it's considered to be in equilibrium. That means that its acceleration is 0. So down here at the bottom, it's got like the sum of forces in the x direction is equal to 0 and the sum of forces in the y direction is equal to 0. So we do have to remember now in 2 dimensions that we might have both x and y values. All right. And so just like in this picture here, and also in chapter 5, we talked about Newton's second law, which was the net force, and that was equal to the mass times the acceleration. So if we're saying that the acceleration is 0, then the net force has to be 0 because anything times 0 would equal 0. And also in chapter 5, we looked at things like this, which was like a free body diagram. So you can see all of these forces are pulling in different directions, but ultimately they are in equilibrium. Okay, so we did this quick check where if you have this string and it snaps, which direction is it going to go? Well, after it snaps, it's no longer in circular motion. So from there, it's just going to be tangent to whatever point it is. So that would be C. Okay, and then it shows this ring that's got these different forces that are being pulled in different directions, and it wants to know how big the force F is. So this one right here. And this is where we said, okay, if we were talking about the force here, does it have any x direction? No. Okay, so if we're gonna solve for it, we're gonna look at these guys right here in the y directions. Well, if we're looking at them in the y directions, if we were going to draw, say, like a coordinate system here, they would both be in the positive y. So we could say 10 newtons sine, theta plus 10 newton sine theta. And then the force is actually going down. So it's minus F is equal to 0 because we're in equilibrium. So we have to equal it to 0. So for solving for F, we're going to move F over to the other side. So we have force is equal to, and we don't know what the angle is, but we could add them together. So we have 20 newtons sine, I just keep doing that, sine theta. Okay, so you end up with E as your answer here. All right, and this is where we did this really big example. It's example 6.1, and unfortunately I probably could actually, now that I think about it, I could show you the book and then we could do the example. So I think that's what I'm going to do. I'm going to stop this video, and I have to make these videos relatively small or else YouTube doesn't like that. So I will stop this and you'll just have to start the next lecture video on D2L.